And the right one is linked to the robot data node. So this was done automatically for us because we used that menu item. Edit, create SubVI. If we did this, we could do this ourselves. If we started a new VI, then this would just be unlinked. So if I disconnect all, it would be like this. And if we look at this guy, it's broken, right? Because it doesn't know what the inputs and the outputs are. The way that you specify the inputs and outputs manually, well, the first step is to choose the pattern. So right now I've got one input, one output, so you see there's 2 blocks. But you can have all the way up to whatever this number is. And you can just basically hook it up like this, by clicking once in the desired block and clicking on the icon, clicking on the control. You see how it went pink? It means that it's linked up. Here, and it's linked up. And then when we save and close this, if you've made those kind of changes to a VI, it's going to go gray. And if you try and run it, it will tell you bad linkage. So what you have to do is right-click and relink to that SubVI. And then you can hook it up again. So what's happened is these wires were in a different location, so that's why they're broken. If I hook them up, I'll just delete this wire first. Then we've got our SubVI. Alright, so what we're going to do in the tele-op SubVI is go to the init case. So the init case runs the first time you enter the tele-op. And this is where we're going to enter in that value for shutoff time. What we're going to just do is we're going to take the current time, and we're going to add 20 seconds to it. Which means we should be able to run for 20 seconds. So open the dashboard up, just leave it to the side, run the main program. See, I'm driving forward, I'm driving backwards, and I've got this dashboard which is showing me that value. And the left encoder is having some technical difficulties. And once 20 seconds have gone by, it's shut down. Okay? The last thing I want to show you with this point of view is, okay, well, we're debugging, right? So that 20-second shutdown, I don't know how that's going to apply with this huge competition. Maybe it's not useful at all. But it's useful as a way to think about, well, what can we do? But wouldn't it be nice to be able to reset that? To have a button on your dashboard which allows you to, oh, I want another 20 seconds. So why don't you show you really quickly how to make that modification. So this is where we take our debug dashboard and we take it to the next level. We take it from an indicator of showing all kinds of stuff to actually allowing us to change important parameters. So if I were to go, I'm going to just go to the system palette, pull up a system button, and call it reset shutdown time. Go to the code. Basically, I'm going to do a case structure here. So if this is true, what do I want to do? Anybody? Well, remember what it is we're storing. We're actually storing the shutdown time, not the elapsed time.
Oh, yeah.
So we want to store, we'll go cluster, bundle by name, take this as an input, put that out as an output, and change the shutoff time. So if that's true, we're going to go to the timing palette, just do the same thing I did before. We'll take the current time, maybe instead of 20 seconds, we'll let this give us an extra 5 seconds. It's going to change the shutoff time. Maybe I'll just move this over a little bit so it's cleaner. And in the false case, if I haven't pushed the button, do nothing. Output equals input. There's one thing I want to talk about before I run this. It's something called mechanical action. Booleans have different ways of running. If you think about a power button on your TV, you push it once, the TV turns on, it stays on. You push it again, the TV turns off. From the point of view of LabVIEW, that's called a switch. That means when you push it, it stays where it was. The other type of button is called a latch. And that's where it's more like the keyboard, the keys on your keyboard. You push the J key, you let go of the J key comes back up. We want a button that behaves like that. We want a button that as soon as we push it, as soon as it's red, it goes back false. Because what's going to happen if it's always true? It's going to keep incrementing the shutoff time every time through, right? And that's not what we want. We just want it to instantaneously change that shutoff time once. And that's why I chose this button from the system palette. I happen to know that this is a latch type boolean. But if you didn't do that, you can always check by right-clicking, choosing mechanical action, and here you've got two sets of choices, the switch choices and the latch choices. You can experiment a little bit, but just be sure you choose a latch one. I advise latch when released. Latch when released, basically, it's like any Windows button. If you accidentally push the close button in Microsoft Word, you say, oh, I don't want to close, and you move your mouse before you let go of the click, it doesn't actually do it. That's latch when released. Okay? So what's going to happen now when I run this? So I'll just move my dashboard back over here. Run the robot main again. We've got 20 seconds of action. I could have made that a little bit less than 20 seconds. So now I'm at the band. Oh. Look like we're having some encoder issues. Okay, now I've shut down. But when I push my button, it's alive again. It's dead. So there's my 5 seconds. Okay? So this is a nice approach. You have to be very careful and understand that this is not the dashboard project. This is not what you're going to be able to use this way in competition, I don't think. This is very distinct from the dashboard project. What this is a great debugging tool that lets you put together all of your probes into one set of indicators on the VI, and also lets you sometimes change these parameters by pushing buttons.